5.2 is about perpendicular lines and angle bisectors. Okay, so the 5.2, 5.3 theorems are all about the perpendicular bisectors. And 5.2 talks about the perpendicular bisector theorem. So if PM is perpendicular to AB, okay, so if they're perpendicular, and AM or MA is equal to MB, all right, so those are congruent, then when you connect the two, so if I go ahead and I connect PA and PB, they're going to be congruent. Okay, and the converse of that is if you have this congruent and this congruent here, then you know that this is perpendicular to MA. Okay, so that's the perpendicular theorem. Angle bisector theorem, again, talks about that. So if QS bisects angle PQR, so we got QS here, which is this line here, bisecting the angle PQR, okay, PQR is on there, then we know SP is congruent to SR. Understand that they got to be perpendicular. So SP is perpendicular to PQ and SR is perpendicular to QR. If that's perpendicular to the right angle in the corner, we know that those are congruent. The perpendicular to the right angle gives me triangles there, which means I can go ahead by angle, side, say they're congruent, which makes that by CP/CTC. That's, again, part of what we've been doing and why we've been doing it, to prove those congruent. The converse that's talked about is if they're perpendicular and congruent. So SP is perpendicular and SR is perpendicular plus SP is congruent to SR. We know that we can have an angle bisector that runs through QS. So problem 1 talks about what is the length of AB. Okay, we have AB at 4x. And since from those previous theorems we know that since BD is perpendicular to AC and AD is congruent to DC, we can go ahead and say that AB is congruent to BC. So knowing that, we can say that 4x equals 6x minus 10. Solve for x minus 6x. I get negative 2x equals negative 5. Divide by negative 2. I'm sorry, negative 10. A step ahead of me. And then x equals positive 5. That's where I got my 5 at. Like I said, I was a step ahead. So when x equals 5, if I'm trying to find the length of AB, understand I got to substitute it back in. It's 4 times 5, which would give me 20. Problem 3 looks like we give an angle bisector here. And again, we're going to use one of those theorems that we just talked about. Since this bisects this angle, and we have RM perpendicular to N, and PR or RP perpendicular to NQ, okay, that's going to end up meaning that those are congruent. RM and RP are congruent. Okay, so we're going to have to take 7x equal 2x plus 25, solve, subtract 2x, I end up with 5x equals 25, divide by 5, I get x equals 5. Okay, it's not the answer to my question. Again, I come back up and I read my question. What is the length of RM? So RM is 7x. So 7 times x, which in this case would be 5. So we end up with 35 for RM.